For the ready portion of lesson 2.2, what we're asking you to do is to just identify what is happening. And if you look at the first example, 4x squared plus 7x minus 6, we need to be able to identify the a value, the b value, and the c value. So it's just being able to interpret and understand what the math is telling us. So for number 1, it might be helpful to underline each of these. 5, positive 3, positive 6. And all you're doing is writing down what you see, okay? Because these are in standard form. Now, if they're not, we have to move them around. We have to do some stuff. But for now, these are in standard form. For number 3, minus 2, plus 3, and then there's nothing on the end here, so we can just say plus 0. So my a is negative 2, b is positive 3, and c is 0. For number 4, it gets a little bit trickier because keep in mind, it's ax squared plus bx plus c. Well, this time we have an a, we have a c, but we don't have a b. So our a value would be 6, our b value would be 0, because again, there's no x term in here, and our c value would be negative 5. For number 6, we have 3 terms, so we've got a trinomial. Our a value is 8, b value is negative 5, c value is negative 2. For numbers 7, 8, and 9, you are multiplying and rewriting each product in the form ax squared, y equals ax squared plus bx plus c. So we're going to take that stuff that we did earlier in module 1 and we're going to put it into practice. So we're going to take that term on the outside and distribute it in. So y equals x times x gives me x squared, and x times negative 4 gives me negative 4x. If you want, you can underline the a, b, and c value. There's nothing in front of the x squared, so we can put a 1 there. Okay, 1 times x squared still gives me x squared. And there's nothing on the end, so I could put a plus 0. Now I'm going to do that, but I'm going to put it into a different color just so that you know I'm adding those on, but I'm still not changing the equation. It's just a way to identify things. So the a value is 1, the b value is negative 4, and the c value is 0. For number 9, do the same thing. Take the 3x and distribute it in. So 9x squared plus 6x, and then negative 2, distribute that in. So negative 6x minus 4. When I combine my like terms, I end up with 9x squared. The plus 6x and minus 6x will zero out, and I'll get minus 4. Once again, we need to be writing these equations into y equals ax squared plus bx plus c format. The trouble is, there's no bx. It's just the ax squared and the c. So that tells me something very, very important. It tells me that my b value is 0, my a value is 9, and my c value is negative 4. Next up, for number 13, we are graphing the equation y equals x squared. So the first thing is I'm actually going to jump ahead a little bit, and complete the table, because the table, I think, really helps us understand what's happening. So for part 13b, we can take that -3 and plug it in for x, and when we square it, we get a positive 9. -2 gets me a positive 4, a 1, a 0, a 1, a 4, and a 9. So just taking each of those numbers and squaring them. Now, I think I'm ready to start graphing. So when I graph them, I need to create an x and y coordinate plane. Make sure that we put the arrows on the ends, and make sure that we label our axes x and y. That's an ugly looking y. There we go, a little bit better. So now I can plot points. So I can plot 0, 0, 1, 1, 2, 4, and 3, 9 will be up here somewhere. Similarly, -1, -2, and -3. So your art doesn't have to be beautiful, just needs to be close. As you can tell, mine is not the most amazing. But what it does is it helps identify what's happening. So the prompt says each side of the axis of symmetry. Keep in mind, the axis of symmetry is that line that I can include that would split it right down the middle and allow it to reflect on one side or the other. Okay. So the vertex of the parabola, keep in mind again, is where my graph changes direction. So in this case, the vertex will be at the origin at 0, 0, because it's going down, 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 and then switches and goes up, 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 up. Okay? So it's just getting us to really understand what is happening with that graph. The next portion, writing the equation of a transformed parabola in vertex form. So find the value for W so that it will have the specified number of x-intercepts. So what we're talking about here is we want to try to have the graph cross the x-axis a certain amount of times. So if I want it to cross twice, I don't want the graph to be up here. I want the graph to be down here. So as we've been talking about, if I want the graph to be shifted down below the x-axis, I need that omega, so that W looking thing, I need that omega to be any negative number. So if I say -5, looking at the graph, I would actually be taking 2, 3, 4, 5, just to make it somewhat, I would be taking that and shifting the graph down 5 units. For number 16, on the contrary, now we don't want 2 intercepts, we want no intercepts. So if we want no intercepts, again, we have our parent graph of this. We have to be able to figure out how we can get it to where it doesn't cross the x-axis at all. Well, that means that we're going to move it up, which means that this omega needs to be positive. So we would just say that omega equals +8 or +44 or something positive so that it shifts up the axis. For numbers 17 through 19, now it's a -x². And as we've been talking about, little bits here and there, that negative is going to take the graph and it's going to flip it upside down. So we have our x and y coordinate plane, and we have our -x². If I wanted this to have two intercepts, I would have to have it move up. Because if right now it's got one intercept, it's got one right there. If I wanted to have two intercepts, I would have to move it up a certain amount. So we would need omega in this case to be positive, 72.84. Doesn't matter. As long as it's positive, it will have two intercepts. Tricky one, and that's the same for this for number 15 as well as number 18. If I wanted to have one intercept, well, this purple function actually only has one intercept because it goes all the way up here, it just kisses the origin, just right there. So what we say now is that this omega is equal to 0. Okay. We're not shifting it up or down. We're leaving it right where it is on the parent function, right touching, barely touching that origin. So it would be 0. For numbers 20 through 25, it actually needs us to graph what we see. And it might sound really difficult to do, but you have access to the parent functions, so you can start by putting your parent function on the graph, and you can do that for each one of these. I'm perfectly fine with you putting that parent function on each one of them, just so that you can see, like, this is how it started. I need to be able to see how it moves, kind of like the recursive and explicit equations, where we want to see where it begins and how it moves. So this is where it's going to begin, but then we need to be able to have it move. In this case, it's saying that the x plus 3, and again, if we go back to some of those graphs and some of those functions that we were looking at before, the plus 3 actually moves us 3 units to the left. So I'll take everything, 1, 2, 3 units to the left, and 3 units to the left, 3 units to the left. So my new function would be graphed right here. And I would just make sure that we have a way of identifying that, y equals x plus 3 squared, especially if you're going to graph 2. Now the next piece for this is the vertex. So the vertex, I've already drawn you an arrow going to it, is actually at -3, 0. Let's take a look at number 24. I'm not going to do number 25 with you. You can graph it, you can see what's happening as a way of verifying. But number 24 is a little bit more challenging because there's quite a bit of stuff that's happening. So the first thing that I can do is I've got my parent function, and I know that I have 3 things happening. I have A, H, and K. A tells me how narrow or wide, and if it's flipped or not. H tells me left and right. K tells me up and down. So I'm going to start with, it doesn't really matter where you start. I'm going to start with K, and I know that I'm going to be moving down 4 units. So I know that my vertex will be here, but then I also know that it's going to move to the left 3 units. So it won't just be at -4, it will actually be at -4 and then 3 to the left, 1, 2, and 3. So it'll be here. Next, I also know that this A is telling me that it is flipped upside down. So I'll go 1 up and over, and then 2 down 4 more, -2, and +2, down 4 more. And you should have something that looks somewhere along the lines of that. Now again, mine is not pretty and gorgeous and beautiful, but it's giving you an idea of how it should be transformed based on the A, the H, and the K values. Your vertex for this, again, is that point where it makes its turn, will be at -3, -4. For numbers 26 through 29, you are trying to work through identifying different parts of that parabola, different parts of that quadratic function that's happening here. So you're going to identify the vertex, the axis of symmetry, any x-intercepts, minimum or maximum values. Okay. So looking at the table, it tells you everything that you need to know. Remember, the vertex is that point in which the graph changes direction. So for 26, it's going 10 and 3, so it's going down, then down to -2, then down to -5, then down to -6. Then it starts to go up to -5, which tells me right here, this is where stuff happens. Okay, this is where the change happens. So I'm going to put a box around that just because that tells me quite a bit of what I need to know. First, it tells me that my vertex is at 0, -6. It tells me that the axis of symmetry is at 0, okay, because this x value is 0. For the x-intercepts, I want to try to see where is this, how many times is this going to cross that x-axis? Well, it crosses it once here, going from -3 to -2, because it goes from +3 down to -2. Then, because I know that it's changing direction here, I know that it's also going to change direction somewhere else down there. So I will say with confidence that there are 2 x-intercepts. I also know that -6 is the lowest this value is going to go. Everything else is going to have to be bigger. So I will say with confidence that this has a minimum value. Next up, for number 27, again, going down, 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 and then stops. So we have our turning point right here, and we know that our vertex would be 2, 1, and we know that our axis of symmetry is at 2. The x-intercepts, if you look at all of these values, they're all positive. So we know that there are going to be 0 x-intercepts. It's not going to dip into 0 or negative territory. Once again, it's starting big, getting smaller, and then getting really big again as we go through. So we know that this has, with confidence, we can say that this has a maximum value. We'll do one more. Number 29. Number 29 is a little bit tricky because it has some stuff going on here that is a little bit different. But we go -9 to -8. So we're going down and are getting bigger, and then we're getting smaller and smaller and smaller and smaller and smaller, and continues on. So we know right here is going to be our turning point. Our vertex would be -7, -8. Our axis of symmetry would be at x equals -7. The x-intercepts, the tallest this gets is -8. Everything else, it's going to get further and further down the graph. So we know that it's not ever going to cross into positive or 0 territory. And because of that also, we know that it has a maximum because it continues going down. Hopefully this helps. Reach out if you have any questions at all.